Okay, everybody take your seats.
I ain't ready, don't go me.
It doesn't matter if you're ready or not. Okay, let me remind you of the protocol. No talking, no devices. Devices need to be face down. I'll write down names of those who violate that. And the more times your name goes down, the more trouble there'll be. Starting when we start. You'll need to be facing the screen. And what I'll do is when each group or person comes up to present, I'll do a countdown, 3, 2, 1, 0, go. By the time we get to go, you need to be done talking and devices face down. And then they will present. Okay? Snap what up. I don't.
I can go like in order.
No, we're going in order. The shelf right here.
I should share mine last.
If you want, it doesn't matter when you share it. If you want, I'll send it away.
But let's not.
Wait, we have to stand up there in front of everybody?
How is she gonna present?
I thought you was
Stand
gonna
right there
present.
at that computer?
No, you gotta click it.
Oh.
Right here's in front of everybody too.
Okay, but I wouldn't. It's already around.
You don't have to face them as long as you're not reading. You can face that way. That's fine. That's fine.
Sit down.
Right here, guys.
It's not all the way finished.
Right here.
Let's get to the front of the screen. Like to see through. Are you made a clash? Is your daddy a classmate? No, he wasn't. So you was made when your dad was 16. Your dad made you 16. All right, let's shut up. Tell you. When did your daddy have you? When did your daddy have you? Like when you were 18, alright, when you stopped being a classmate?
They were really big down on the surface side.
You're not gonna be the only one.
Your daddy wasn't a classmate.
Okay,
Oh my God.
Alicia's first up.
Alicia.
Clicker, you can use your
Johnson
mouse.
Got the same presentation.
So heads up, devices down, mouths closed and listening. You do not have to write anything down. Okay, but I do need you focused and ready to go. Okay? All right, you may begin in 3.
Johnston.
That's fine. 2, 1, go.
Okay, so my presentation was on in speed and insects. Alright, speed is the rate at which someone or something is able to move or operate. But the reason why insects travel at different speeds is because of like their size and their mass and how much their wings can like take. Stuff. Okay.
That was good, actually. Guys, whenever you've got to talk to a group of people, never tell them you're not ready. Never. Fake it till you make it. Okay? Pretend like you know what you're doing. I'm serious. No one wants to hear how unprepared you are, and I'm not. I'm going to give you extra credit because I'm saying this right after you. Okay? It's not about you. It's about faking it till you make it. Okay? So don't ever tell anybody how unprepared you are.
Mr. Taylor.
This is way better than taking a test though.
Taylor.
Yeah, it is.
Did I finish my lesson? Did I finish my lesson?
It's too late.
How's it too late?
This is the exam.
All right, Med is up.
Okay, so
Hold
my,
on, hold on. All right, 3, 2, 1, go.
so my presentation is about alpha particles and radioactive decay. An alpha particle is an atom similar to helium with 2 protons and 2 electrons. By escaping the parent atom, the alpha product of alpha particle and the nucleus become positive. This changes the atom into a different element. To get a new atom, you subtract 4 from the mass and 2 from the atomic number. The alpha particle is only really hazardous when it's eaten because it doesn't release much radiation, so it wouldn't cause much damage just from the outside of your body. And radioactive decay is just radioactivity, and radioactivity is when particles are projected from the nucleus because of nuclear instability, and radioactive decay rates are based on the particle structure.
So you guys got to all.
All right, Caitlin. You can use the clicker, you can stand back there, whatever. All right, 3, 2, 1, go.
Mine was on Newton's first law. What is Newton's first law? Newton's first law states that objects in motion will stay in motion, while objects in rest will stay in rest, unless acted upon by an unbalanced force. It is named after him because he invented it. How does Newton's first law affect how you eat? Your teeth play a part when breaking down your food. When you chew, your teeth are moving until they know you can't move anymore, and that's how it breaks up your food, if that makes sense to anybody.
Sierra's here. No. Come Clay.
Wait. We got a couple better, so.
We're not being critical of other people's presentations.
I didn't say anything.
Wait, ours isn't online.
No, we're not showing the videos because of time. We don't have enough time to watch all the videos that should be in your presentation. All right.
Can I stay back here?
Sure. All right, we ready? All right, 3, 2, 1, go.
My presentation is also on speed and insects. What is speed? Speed is the rate at which someone or something is able to move or operate. Why do insects travel at different speeds? The reason why different insects travel at different rates is because of their size. And then these are some type of insects that move fast. I think that's a mosquito. It might be. Huh? Oh, a dragonfly, and then a bumblebee. It's a dog. Yeah, right there. And then these are some types of insects that move slow, and that I don't know what that is.
Stink bug.
There's a stink bug and a beetle.
Yeah.
Yeah. And yeah. And that's not finished. But that's it.
All right. Whoopsie, you're on.
It's like a mosquito.
Mr. Taylor, is mine on there now, cause I saw where it was sent to you. Oh, I'll go next.
Okay. All right, devices, talking,
How do I do this?
mouse or the clicker. All right, devices talking, 3, 2, 1, go.
Okay, I'm doing Newton's first law, and there's a picture, and it's kind of showing Newton's first law, and it says that an object that is at rest will stay at rest unless acted on unless an external force acts upon it, and an object that is in motion will not change its velocity unless an external force acts upon it, and then I showed an example of it. And then it's named after him because Sir Isaac Newton discovered the 3 laws of motion, and that's why they were named. And there's a little diagram of Newton's first law, and it can affect the way you eat because an object in rest stays at rest, and you can't eat without applying force to the food you're eating because the food can't feed you itself, so you have to act on that force. I guess that's it. I can't really.
Well done, well done.
Erica?
Let's go, Eric.
All right, everybody ready? 3, 2, 1.
As y'all can see, I did speed and insect. Said a little walk, yeah. Push how the thing is behind us, you know. What is speed? Speed is the rate at which something moves swiftly. Why is it good to be a slow insect? Being a slow insect is good because it most likely has camouflage so you can hide the prey. Yeah, why is it good to be a fast insect? Being a fast moving insect is good because it can catch the insect because it can catch the insect, can catch its prey quickly, and it can also get away from its predator.
Mosquito.
The dragon.
Dragon black.
Mosquito.
They're my big lovers.
Actually, 3.
Right.
But you had, the same thing as mine.
All right, here we go. All right, so 3, 2, 1, go.
All right, so my project is Newton's first law. Well, Newton's first law states that an object that is in motion will not change its velocity unless some kind of outside force is applied to it. Same goes with an object at rest. More information, you can go there, Taylor. Why was it named after him? Well, it was because it was named after him because of his accomplishments in the science field. Revolutionary science. How does it effectively eat? It effectively eat because it would require motion and force. It's applied when you eat food with a fork or even if you're fed through a tube.
there any way you can? Huh? Is there any way you can do yourself?
You're not supposed to be on Zoom.
I got two. My name tag and Melissa.
All right, just go.
Oh, yeah, I'm 34.
There's no minimum requirements, so you're fine. As long as you cover materials, you're good.
So, yeah.
All right, everybody ready? Okay, walk this into around.
Alright, well, I did Newton's first law. What is Newton's first law? Newton's first law is an object in motion tends to stay in motion and an object at rest tends to stay at rest. Why is it named after Newton? Because he is the one that figured out that the objects in motion stay in motion, yeah, all that good stuff. So he got that himself. And I didn't write anything on that one, but it's because you have to apply force and all that good stuff, so yeah.
That's very scientific. Austin, you need to turn around during presentations. By the way, I've got Jordan. Didn't I just catch you on your cell phone?
Oh, I did.
That's why I walked up here and
Just
pointed
saw
at
you.
you and Tristan, because you're both on your phones. All right. Catherine and Kat. You go who? You're next, sure.
You got this, you.
Can I go next?
If you're next, yeah.
That's a good one, too.
All right. By the way, you can be on devices while we're setting up the next presenter, so that's okay. No, don't even present. I'm not stupid. All right, here we go. 3, 2, 1, go.
We did noble gases, we forgot to add it, but. Okay, we chose noble gases. Noble gases are any of the gaseous elements helium, neon, argon, krypton, xenon, and radon. Occupy group 0 or 18 of the periodic table.
They were long believed to be total unreactive compounds of xenon, krypton, and radon are now known.
The history. The noble gases, group 18, are located in the far right of the periodic table, previously known as Ensberg gases.
The first person to discover the noble gases was Henry Cavendish. Henry Cavendish discovered it in 1875.
Argon. In 1894, argon was discovered. It was discovered by John Williams Rudd. Large unknown gas was present in the air.
With the aid of William Ramsay, he managed to replicate it and modify his experiment to better understand the interest.
Helium. Pierre Jensen first obtained evidence of helium. Symbol of helium is He, and Norman Lockyer confirmed this.
Neon. Facts. Neon was discovered in 1898 by William Ramsay. This wasn't his first element discovery.
Xenon. Symbol Xe, atomic number 54, and it's a colorless gas.
Krypton. William Ramsay discovered this in 1898. He also discovered neon.
Hydrogen. Facts. Its atomic number is 1, it's a colorless and odorless and tasteless gas, and also non-toxic, non-metallic, and it glows in a plasma state. And those are pictures. The hydrogen's the first one, and then it goes across, and then argon, and across.
Really like how you show the color of those gases. That's how, I'm sure that, those are how, that's how they find, that's how they figure out what planets and stars are made of. Is by how those objects glow under a
So
particular
Saturn,
telescope.
Saturn is the one in the middle of the
Come on, man, what are you doing? You have to have a specific kind of spectral telescope to see it. You can't just say, oh yeah, that's Saturn.
No, but you said about the color. And the
You
color,
have to have the right device to do it.
I know, but the
Can't measure
color.
by eyesight.
Oh,
All right, Lee.
Maybe you just want
All right, everybody turn around, looking, devices down, face down. I'm talking, here we go, 3, 2, 1, go.
Alright, I did mine over force and car accidents. Force is the act on an object that changes its position by pushing or pulling on the object. There's a formula to figure out force. Alright, when you're driving your car, these are all the forces that are acting on the vehicle. Alright, what does force have to do with a car accident? Oh man, that's not words. A car accident creates force between the vehicle and the object that got hit, forcing the two objects to push back on each other, creating the disaster. Also, the force can be determined through how fast the car is moving when it crashes. This is, showing you basically the car crashing into a tree, and then it shows you, all the forces that are acting on it. This is the same, but after it is done collapse.
slam me again. I'm not playing. I will leave you, bro. I will put you in your activities ever again in my life.
How many? How many?
I'll cut you a call.
You know how people don't like to be touched?
I don't care. He had no reason to snap.
I'm telling you, don't touch people.
I was always talking about you.
All right, Leslie and Tony.
Look what you did.
Okay, devices down, I'm talking. Facing screen, 4, 3, 2, 1, 0.
Alright, our PowerPoint is over in stress law.
Okay, how does Newton's first law affect the way we eat? When the food is in our mouth, it will not move until force is added to it, which is when we chew it. As our teeth are hitting it as well is an example of Newton's first law.
Why was it named after Newton? He was a very knowledgeable scientist about science that many other scientists were so surprised about him, knowing so much about motion, force. They decided to name it after him.
It is an example of Newton's first law. In order to push an object, you have to have force to it, and then it will change position.
Alright, this slide basically states that an object will not move until force is applied on it.
Here's I've got the projector.
Go Anna.
3, 2, 1, go.
Reading Newton's first law. This is a picture showing and explaining that basically is explaining how Newton's first law is explaining inertia, and that an object won't move unless there's an applied force greater than the mass of the object. And it was named after him because of his achievements in the field of mathematics and astronomy. how does it affect while you eat? It affects the way you're eating based on how your jaw goes against the object of food you're eating. Our teeth that going against the object is creating an unbalanced force upon the object and
All right, Olin? Huh? Oh, yes? All right, we're ready. Devices talking. 3, 2, 1, go.
I did velocity in race car driving. What is velocity? Velocity is the speed of something in a given direction.
When race car drivers are done with the racetrack, loops around a track, what is the next velocity? The consistent speed, the constant speed they are going.
Why do race car drivers need to understand velocity? They need to know how far the car will drift when going around curves to make sure they don't flip their car. And then that's
All right, Tristan?
That's it.
Okay, all right, hold on. Okay, devices talking. 3, 2, 1, go.
Newton's first law. What is Newton's first law? Newton's first law states that an object at rest stays at rest, while an object in motion tends to stay in motion with the same speed and in the same direction, unless acted upon by an unbalanced motion. Named after Newton. In physics, a Newton is a force over a unit area. It was discovered and therefore named after its founder. Why does Newton's law fit? All objects like to keep on. All objects like to keep on doing what they are already doing.
Yeah, it is.
All objects like to keep on doing what they are already doing and will resist any change until a force causes them to. Resource.
What's that many of you guys are choosing Newton's first law? Not a problem.
I chose this on because
Just
I think you found information on this. You had to do it on whatever you did.
Oh, I thought that's what you had. Mine was Newton's first law.
I was just saying it might be something.
Yeah.
I got it for next. No, I'm getting the
Camera raises.
That's all you did, boy. Give me the clicker.
Jordan.
You wanted the clip was young.
We had Newton's first law.
3, 2, 1, 0, go.
What is Newton's first law? Every object in a state of uniform motion tends to remain in a state of motion. Like sun or whatever. Wallace is named after him. In physics, a Newton, which is N, is a force over a unit of area. It was discovered and therefore named after its founder. Well, I mean, y'all could come up here and say.
Oh, okay.
Yeah, that's it.
You can go.
Say something.
How does Newton's first law affect the way you eat? All objects like to keep on doing what they were already doing, or just to change it to a force causes them to. Sorry for the bad graphics.
And that's like videos that we put up there, pictures and stuff.
Obviously.
Okay, yeah. Those are all 3 questions. You can count?
Good job, Jordan. No plastic.
I'll be down here tonight. I'll be here till 1:27. Back there.
All right, Mr. Ed. You want the clicker or you want the mouse? All right, ready to begin? 3, 2, 1. Go.
Alright, so my PowerPoint's on gamma rays and radiation protection. I flip on it. I don't know why that's not okay. Alright. Gamma rays were first discovered by Paul Diller, a French chemist and physicist who discovered gamma radiation in 1900 while studying radiation emitted from negative. And gamma rays are ionizing radiation and are thus biologically hazardous. And gamma rays are usually emitted during nuclear fission and nuclear explosions. How does a gamma ray relate to radiation? This is a fun fact. Gamma ray bursts can release more energy in 10 seconds than the sun would emit in its entire 10 billion year lifetime. Ooh. And this picture is an illustration of emission of a gamma ray from an atomic nucleus.
That's all right. That symbol right there is actually gamma. Okay, so that's, they use that symbol to name it. I don't know why, but it's okay. All right, Peyton, Brianna, Faith Rosenbaum. Carl Wilson.
Huh?
Okay, all right, well, George and them are ready now, or not George, I'm sorry. Peyton. So here we go, 3, 2, 1, 0.
Well, our PowerPoint is about free falling and skydiving.
Okay, free fall is a special type of motion in which the only force acting upon the object is gravity. Objects that are falling under the influence of free fall are not experiencing a great amount of air resistance. Therefore, they're left under the sole influence of gravity.
If you were to jump from a very high height, really high up, you would gain speed when you come down. Where if you gain about 10 meters per second when you're falling.
Can skydivers control free fall? Yes, they can control free fall. Once the skydiver pulls the string for the parachute, then it adds a tremendous amount of their resistance. The amount of resistance added to the skydiver slows them down enough to safely land on the ground.
This is our video.
I'm gonna watch some of those videos.
I'm on the side of it. Well, actually, I won't be saying that because I do have I'm gonna have a heart attack every day. Would you?
Hey. Excuse me. There's exams going on in rooms next to us, so you still need to keep it down. You can whisper, but you're not gonna be shouting like that. Whatever.
Have a good example of course.
Hey. Yes, sir.
Ready?
Nice. Hey, we're going into whisper zone only. If you don't know what whisper is, if you can hear tone in the voice, that's not a whisper. This is a whisper. Whisper only. Yes. Leave me on your phones for a minute. Guys, if you can't keep whispering, we're gonna go no talking at all. You have makeup work, there's laptops here. I've got on the bottom of the cart.